Assalamu alaikum, dear students. So students, in this lecture I am going to be covering problems that relates boats and trains to your textbook. Okay, so without further delay, so let's get started. Okay, you first need to understand some criteria in order to solve problems related to boats and streams. So direction along the stream is called downstream. So downstream means you are traveling in a boat in the direction of the stream. That means the direction, say for example, if the direction of the stream is on your right, then on right side, then you are traveling on the boat on right. Okay, so that means direction along the stream. So if you are traveling in direction of a stream, then you are on downstream, right? So direction against the stream is called upstream. As you can see from the picture on my right, means upstream means direction, a flow of a stream is on my left and direction of the boat is on my right. That is why it is called upstream. And again, from the picture below, the flow of a stream is on my left and the direction of the boat is actually on my left. That is why it is called downstream. So in when a boat is on downstream, its velocity increases, right? So speed along the stream equals to speed of boat plus the speed of a stream. And this actually meets the second picture on your right, because when you are traveling along the stream, your velocity actually gets increased by the stream. Say for example, if you are traveling 2 meter per second and the velocity of the stream is 1 meter per second, and if you are traveling along the stream, then your velocity would be 2 plus 1 equals 3 meter per second. Well, that would be the actual velocity, right? Now speed against the stream, that means speed of boat minus speed of stream. That means when it actually fits into the picture, first picture, right? So speed against the stream, it must be speed of the boat minus the speed of the stream. So let us see those things into action. Okay, this is math number 17 from your textbook, chapter 2.3. A boat can cross 36 kilometers in 4 hours along the current. If the speed of current is 3 kilometers per hour, what is the speed of boat in still water, right? So in the first line, a boat can cross 36 kilometers in 4 hours. Okay, I can see that speed of the current is actually 3 kilometers per hour, but a speed of the boat is not given. But in 4 hours the boat can travel and 36 kilometers. So in 1 hour the boat can travel 36 divided by 4 equals to 9 kilometer. And you all know that distance travel in unit time is called the velocity. So here the distance is 9 kilometer and it is in unit time because the time is 1 hour. So if the time happens to be 1 minute, and then it would be a velocity. If the time happens to be 1 second, then it would be again velocity. That means if your distance is on a unit time, then you are having your velocity. So in this case the velocity is 9 kilometer per hour, as it is the distance covered in 1 hour. So this is actually speed of boat along the current. This is not actually the actual speed of the boat. This is the boat, this is the velocity, I mean a speed of boat plus the speed of current. This is what it is actually. So in this problem, the speed of boat and the speed of current, they are on same direction. Okay, so that is why we need to add those two. Speed of a boat, actual speed of boat plus the speed of current, if I add those up, then effective speed of boat will be occurred. So speed of current is given, and the effective speed of the boat is also given, and it is 9, right? So actual speed of the boat, that means effective speed of the boat along the current minus the speed of the current. So effective speed of boat along the current is 9 and the speed of current is given and is 6. So that is why the speed of the boat in still water is 6 kilometers per hour. Okay student, let us see our next problem in this row. Okay, this is a problem number 18 from your book. A ship can travel 77 kilometers waterway in 11 hours against the current. If the speed of the ship is 9 kilometers per hour in still water, what is the speed of the current? What is the speed of the current? Okay, so a ship can travel 77 kilometers waterway in 11 hours against the current. Well, this problem is a little bit different from the previous one, right? It is against the current, and 77 kilometers in 11 hours, that means 77 kilometers per hour is not our velocity. We need to divide 77 by 11 to get the velocity, right? And speed of the ship is given. What is the speed of the current? Speed of the current, it is to be determined. Okay, now speed of the ship is 9 kilometers per hour, and in 11 hours the ship can travel 77 kilometers. So in 1 hour it can travel 7 kilometers. As 7 kilometers is actually the distance in 1 hour, we can treat it as our velocity. So in this case our velocity will be 7 kilometers per hour, because 7 kilometers is the distance traversed by him, and in 1 hour, so it is 7 kilometers per hour. It's our velocity or the speed. So we are actually going against the current. That is why boat, direction of boat and direction of current, they are opposite. So effective speed of ship against the current, well, there would be a minus sign because we are going into opposite direction. So actual speed of the ship minus speed of the current. So what we need, actually we need the speed of the current. So speed of the current would be actual speed of ship minus the effective speed of the ship against the current, and in this case actual speed of ship is given and it is 9, and effective speed of the ship is 7. So by subtracting 9 minus 7 we get 2 kilometers per hour. That is why the speed of current is 2 kilometers per hour. Okay, now let us see another problem. With the help of an oar, a boat can travel 3 kilometers in 15 minutes along the current, and against the current it travels 1 kilometer in 15 minutes. So determine the speed of boat in still water and the speed of current are the most simplest problem. Well, this math actually looks big, but it is not that big and so simple, right? 3 kilometers in 15 minutes, that means we have a velocity. We can find the velocity here. In 15 minutes the boat can travel 3 kilometers. In 1 minute the boat can travel 1 by 5 kilometer, because 1 by 5 is actually the distance in a unit time, in this case 1 minute. So we can treat this one as the velocity. So in this case the velocity will be 1 by 5, velocity or speed will be 1 by 5 kilometers per minute, not hour. Okay, now let us go against the current. So in against the current it actually travels in 15 minutes 1 kilometer. So we need to find in 1 minute. So okay, effective speed of boat along the current is actually equals to actual speed of boat plus the speed of current. Okay, this one is on along the current. So along the current, speed of boat along the current is given, is derived 1 by 5, and actual speed of boat is not given, speed of current. Okay, let us substitute the values. Actual speed of boat plus the speed of current equals 1 divided by 5 kilometer per minute. So this is equation 1. Okay, let us go to the next statement. Okay, in 15 minutes the boat can travel 1 kilometer. In 1 minute the boat can travel 1 divided by 15 kilometers. So 1 divided by 15 kilometer is the distance in 1 minute. That is why this is actually the speed of the current, and that is speed of boat along the current, and it is 1 divided by 15 kilometers. So as we are traveling against the current, so the line should be like this: effective speed of boat against the current actually equals to actual speed of boat minus speed of current. Now substituting the value, so actual speed of boat minus speed of current, it would be 1 divided by 15 kilometers per minute. Just look at those two equations, equation 1 plus equation 2. If you add those two equations up, then speed of current will be cancelled, right? So 2 times actual speed of boat will remain. As you can see, I have added those two, so speed of current actually cancels. So 2 times actual speed of boat equals 1 over 5 plus 1 over 15, and it is 4 over 15. So actual speed of boat dividing it by 2, then we get 8 kilometer per hour. Yeah, it's 8 kilometer per hour because I have multiplied it by 60. Okay, that's cool. And if I subtract 1 from 2, then actual speed of both cancels. So 2 times speed of current actually equals to 1 over 5 minus 1 over 15 equals to 2 over 15. And speed of current is 1 over 15 kilometer per minute. And multiplying it by 60, we get 4 kilometers per hour. So that is actually, these are the two answers marked red, 8 kilometers per hour and 4 kilometers per hour. That's the answer to the questions. Okay. So we have solved 3 problems that relates that concerns boat. Okay, now we will see some different problems with trains. From, say for example, this is a man, a train actually wants to pass him. Look what happens. Okay. Whoa, when a train actually passes a man, the length of that man is negligible, and the train actually passes the distance of its length, right? When your a train passes a lamp, passes a stamp, standing man, or a stick, then it actually passes the distance equal to its length. Okay, because the length of that pole or that stamp is actually negligible. That is why when a train passes a man or a pillar, then it passes the distance equal to its length, because that distance is negligible to the length of the bigger train, right? So say I have taken this problem from your example. When the speed of a 60-meter long train is 848 kilometers per hour, how much time will the train take to cross a nearby pillar of the rail line? And you have seen from the previous slide that when a train passes a pillar, the distance of the pillar is negligible, and the train actually passes the distance equal to its length. And in this case, the length of the train is 60 meters. So when it passes a nearby pillar, it actually traveling 60 meter. Okay, not more than that. Okay, to cross the pillar, the train has to pass the distance equal to its length, because the length of the pillar is negligible, and 48 kilometers is equal to 48,000 meters. Okay, that's cool. The train crosses 48,000 meters in 1 hour, and the train crosses 1 meter in 1 over 48,000 hour, or 60 times 60 divided by 48,000 seconds. Okay. Now the train crosses in 60 meters in 4.5 seconds. The train will cross the pillar in 4.5 seconds. That's the answer, because when the train is actually crossing that pillar, it actually crosses 60 meters, right? Okay, that's the problem. That's the most easiest problem. So let us see some more complicated problems with trains. Okay, look at this picture with careful attention. Now this time your train will not pass a pillar but a bridge of 200 meters. See that, right? You're watching that. Okay, now as you can see that when the train passes that bridge, it actually passes its length plus the length of the bridge, right? Okay, when a train passes a platform, then the distance covered by the train is equal to the sum of the length of the platform and the length of the train itself, as you can see from that slide. Okay, let us now solve a problem with this criteria. The speed of a 100-meter long train is 48 kilometers per hour. The train crosses a bridge in 30 seconds. What is the length of the bridge? Well, you know from the previous figure that when a train actually passes a bridge, then the distance covered by the train is actually the length of the bridge plus the length of the train itself. So in this case, the length of the train is 100 meters, and the length of the bridge is to be determined, and the speed of the train is 48 kilometers per hour. That means in 1 hour the train actually travels 48 kilometers, right? And that train crosses a bridge in 30 seconds. Okay, when a train crosses a bridge, it has to pass a distance equal to the sum of its length and the length of the bridge. Okay, here 30 seconds is 1 divided by 120 hour. Okay, that's nice. Now, according to the question, in 1 hour the train crosses 48 kilometers, because the speed of the train is 48 kilometers per hour. So as the train crosses the bridge in 30 seconds or 1 by 120 hours, so in 1 by 120 hour the train crosses 2 divided by 5 kilometers or 400 meters. Okay, that means it is actually now we are now certain that in 30 seconds, as you can see from the question, in 30 seconds the train actually crosses a bridge, right? Yeah, and when a train crosses a bridge, it actually crosses the distance equal to its length plus length of the bridge. In 30 seconds it actually travels 400 meters. That means the length of the bridge is actually 300 meters, right? So the length of the bridge is actually 400 minus 100 equals to 300 meters. That's the question is all about. If you do not understand this, I suggest you to pause the to review the previous slide that actually shows you when a train passes a bridge, what happens then. Okay, so in this case it is 400 minus 100 equals to 300 meter. Now there is another problem that relates train. A 120-meter long train will cross 330-meter long bridge. Okay, the length of the train is 120-meter and the length of the bridge is 330 meters. So when the train crosses that bridge, it actually the distance traveled by the train will be 120 plus 330. Okay, if the speed of the train is 30 kilometers per hour, then how much time will the train need to cross the bridge? It is question number 24, by the way. Okay, so as you can see, so the distance passed by the train is actually 120 plus 330 or 450 meter, because when the train is passing a bridge, it actually traversed a distance equal to sum of the length of the train and length of the bridge itself. So 30 kilometers is actually 30,000 meters and 1 hour equal to 3600 seconds. So the train crosses 30,000 meters in 3600 seconds. So the train crosses 1 meter in 3600 divided by 30,000 seconds, and actually the train crossed 450 meters in 3600 by 30,000 times 450 equals to 54 seconds. Hence 54 seconds will be required to cross the bridge. Well, that's it. Well, no problems for today, only one problem, and this is actually a previously assigned homework to you. I consider it to be solved in this class, so let us try to solve this one. Okay, well, there are two inlets, right? So one can fill it in 45 and the other one can fill it in 36 seconds. So another outlet pipe can empty the tank in 30 minutes. So firstly, the inlet pipes are opened. After 7 minutes, the outlet pipe is also. So for 7 minutes, the inlet pipes were active. So part filled by the inlet pipes in 1 minute is 1 divided by 45 plus 1 divided by 36 part, right? So the part filled by the inlet pipe in 7 minutes is 7 divided by 20. And the remaining part is 13 divided by 20, right? Okay. And okay. So part filled by the first, second and third pipe in 1 minute is 1 divided by 45, 1 divided by 36 minus 1 divided by 30. Well, I have put a minus sign over there because that third pipe can empty the tank in 30 minutes, right? So 1 divided by 60 part can be filled by the 3 pipes altogether if you connect them in 1 minute, and your remaining part is 13 divided by 20, right? So 1 by 60 part can be filled in 1 minute, so 13 divided by 20 part can be filled in 39 minutes, and we actually filled for 7 minutes. Okay, so the total time is 7 plus 39 is actually equals to 46 minutes. So I consider this problem worthy of your exam and a very good problem actually. So you should all try to solve this problem repeatedly. Okay, thank you very much for your patience. So let us see if we